So I guess it's worth talking about things that are still not automated or inherently hard to automate.
Oh, okay.
We could do more.
I don't have as much on the not automated.
None of us do.
Because we're so automated.
We're so automated. Yeah, we have this guy who calls people on a telephone. It's really not automated. It's just this one guy.
But one day it will be automated.
One day it'll be automated. We're here today to discuss a topic of automation. We've got a broad panel of people here today from across Algo to talk about what automation at HRT means to us and what the abstract idea of automation is in practice. So I guess we should start with a discussion about what automation even is. I mean, I guess it's do things automatically, but for me, there's like a kind of set of things that need to be done to make our trading happen, all the way from like research to live production trading. And many parts of it can be done automatically or manually, and can be done faster or more efficiently. So I kind of think of automation as encompassing that whole span from like idea and data through to a live trading environment and maintaining that.
I would say that kind of aligns with how I think about it. A lot of the time people will have some kind of research idea, and if you sort of oversimplify things, you could just say, try the idea out, see if it works, but really there might be hundreds of different tests that you might want to do on every idea, and there's no way you can do it all manually, so you have to automate.
Right.
In general, if you find yourself repeatedly manually doing the same thing again, that's like probably when like automation should have just like kicked in. And and I think at HRT we try to do more of that.
Oftentimes we do automation when we find out that we're doing repetitive work. So that's when you automate some manual workflow that already existed. But oftentimes we also find ourselves doing some kind of preemptive automation where we're like, oh, we expect us to do this thing over and over again. So we start by making tools or making an abstraction layer. And oftentimes one effect that I had observed is that people would eventually leave to fit their ideas into a pre-existing automation workflow, which might prove to be the right decision sometimes, but probably not the best decision all the time.
It's like maybe someone vaguely wants to do something, but it's like daunting because it's too much work to even like try the idea out. But if there's some like way that's already like some magical device that you've anticipated, you kind of like actually open up a whole new like lines of investigation and an opportunity.
The crux of the idea of automation to me is like raising the abstraction level of the key primitives that you work with. So it's when you're trying to do something, you only have so many brain cycles to do it. And if there are some things that you don't care about, a machine should take care of that for you. So for example, if I want to put up new trading, one approach might be I have to copy a file from this directory to this directory. I have to set these parameters in so way. Or maybe if I find myself doing the same thing over and over, I can create a new primitive called put up trader, and then just like invoke that in my brain every time I want to do it.
So automation is kind of like abstraction as well.
Exactly. And I think there's the same idea of like, in the same way abstraction layers can be leaky, like automation can be bad. If you automate things poorly, the primitive doesn't actually map to what you actually want to do in your brain, then you can like cost yourself time even though something might seem more automated.
That's true. I guess by that same principle, there's also like standardization. Like if you want to do the same thing every time, I guess one thing we often do is like check the results of a research idea, like a new predictive model, and we always want to like compare those results in a standardized way. That's going to have a form of automation. Like we've abstracted over the question of like measure performance. And it's like a standard box, a performance measurement box, and you want to do that automatically and in a standardized way every time.
And it's not just a matter of saving time, because a lot of the time if you wanted to compare experiments, it might be difficult to remember if you did the exact same set of measurements and you might not be comparing things fairly. The other thing is sometimes you might be doing some process that has dozens of steps, and you happen to know that today you really care about the 10th one, but there's a few details at other steps that, it would be better if you made this adjustment. But if you sort of automate it, then you can make sure that each step has been carefully designed and you do it perfectly every time.
Yeah, I mean, I think the way that HRT has thought about automation has actually been pretty consistent over the 10 plus years I've been here. I think automation is it's such a key part of our DNA because HRT started with a bunch of developers who had some taste in trading. And I think from the very beginning, there was this idea of, well, let's take the thing that we're doing and let's automate it. We've certainly gotten better at it over time. We've learned lessons about what's easy to automate and what's not, for sure. But yeah, this core idea of, okay, right, if you ever find yourself doing a thing more than a few times manually, you should really think of a different way to do it, has kind of persisted throughout. I think this idea that Kevin was talking about earlier about like finding the right layer of abstraction has also been really important for us to be able to scale to different markets, because like if you can find the right level of abstraction where, right, under the hood, every market has its own tricks and things, but right, if you can kind of get them all to look the same, right, then it's very easy for you to then build on top of that layer and say, okay, well, we're going to take this trading strategy, or we're going to take this research workflow and just apply it to every single market that we can.
I mean, I think we do a pretty good job. So, for example, we do not write signals that are market specific for the most part. We write centralized signals that work everywhere, and they consume this common abstraction, and it seems to work pretty well. We've also noted that some market-specific quirks don't fit neatly into this framework, and our objects and classes do allow us to like punch through and reach down and get market-specific details when we need to. So I think overall, I'm pretty happy with the abstractions that we've built.
It's hard to, I guess, like the hard question, is this abstraction or is this automation? I don't know. Is this market abstractions or market automation? So, we've made our trading strategy. We've pushed the automation red button, and it's gone and it's trading. It's running live. Like, what does automation mean at HIT for sort of live trading?
We trade so much that automation just has to be deeply intertwined with our trading. So for example, there's no human in the loop. And it also would be completely infeasible to have a human like monitor our trading and decide to like hit the big red button and turn it off if it's going wrong. I mean, everything's just happening at too quick of a timescale for something like that. So we have to deeply intertwine automation with our notion of live trading monitoring. So for example, what does that mean? That means that if something's going wrong, probably a computer needs to be able to detect if something's going wrong and take the necessary action, not tell a human to do that.
Some people in this industry do have a lot more humans in the loop than us. And I guess one of the things that's interesting to think about is like, why or what are the consequences of that choice? I think one consequence is scale. Like HIT does a lot with less because of our embrace of like automation.
I think when I first started at HRT, I never actually worked at a finance company per se. So my expectation going into the company is that I will have to look at things with my eyes and do things with my hands a lot. Well, I did end up typing a lot, but I think I was definitely amazed by how little people actually depend on their eyes and brains to make certain judgments. Because we do hire good people, but people would always tend to make mistakes. So I think one philosophy when it comes to live trading is to automate everything. And whenever we can't automate the thing, we try to automate as much as possible. I think that's not to say to take away the human part completely, right? But to facilitate that part with as much automation as possible. I think that's why we can make use of our talent in a very efficient way. It really amazes me how how such small teams could be trading so many things everywhere all at once. So yeah.
I think a lot of it, maybe automation is even the right word for this aspect of it, but the fact that we try to make things common across markets helps quite a lot. A lot of the time, you might discover some way to make a particular part of the code faster, and you don't have to implement it 20 times. It also means that if there was a human in loop in some aspect, like you wouldn't have to make this part of an operational playbook in a ton of different markets. You can improve the system in one place and affect it everywhere.
Yeah, I think one non-technical thing that initially when I first joined HRT amazed me was that like HRT goes on this company trip every year or so ish, where there's when there's just very very few people actually still maintaining or monitoring stuffs, but yeah, and HRT is still fine. We're still able to trade on those days, and this really says how much automation we put in.
Yeah, also like, people eat lunch in our cafeteria, like they don't eat at their desks. I think that also says a lot about just, how little on a typical day we have to be looking at things.
Another interesting thing is like you can look if you want, I guess. And like, it's not to say that we are like sort of fire and forget with these things. We do look at like our live trading performance, and we do look for things in a more like less in like a reactive way, but more in a like kind of diagnostic way to like make that trading better. Our market share was like abnormally low or abnormally high on this day. Like, can I go then retroactively and like look at the system and understand it and like break through the abstractions available to us and like then dig deeper and like make those research decisions that like improve trading going forward.
I think that is a very good point when it comes to automation, because oftentimes I think visibility is the top, at least among the top three feature requests that we get from our users. Because I think oftentimes when you do a really, really good job at automating something, when time goes on, the users tend to be detached from the task that's actually being carried out, and they become less familiar with the very idea that they're working with. So if they keep working only at the high levels, they tend to get rusty when it comes to digging down to the deepest level and understand the nitty-gritty stuff that's going on there. So I think providing visibility to our users, researchers, really make it so that they can do good research. They can find small things but make big changes out of it.
Yeah, I feel like that reminds me of like a lot of like discussions that I've heard about even planes being on autopilot, right? And I think like most pilots actually will manually sometimes like steer the plane or do whatever, right? Because if you just rely too much on the autopilot, you forget what to do, right? And so I think finding that right balance is important.
So a lot of the time, the individual steps might be fairly simple. We need to grab this thing and convert the format and save it in a file so we don't lose it. But then it's like, well, we might have dozens of variations of it. There might be a long history that we need to pull. There might be all sorts of reliability checks that we need to do. Maybe sometimes the vendor will send us data that's just empty today. Will we notice? So there's just all sorts of things that we need to check on every single data set every single day. Maybe we had a bug in how we processed the data. We might need to think about that and say, well, maybe we shouldn't just grab it, process it, and save it. Maybe we should save it how we got it, process it, save it in a process form so that we can rerun the code we used to process it. There's all sorts of little considerations like that. And in isolation, it's not such a big deal. But when you talk about tens of thousands of data sets, there's a real scale problem here. And you have to build systems specifically to address this kind of thing.
Yeah, I mean, one thing that I think quickly becomes clear as we're trying to push for automation is the real world is messy, right? And when we're trying to take in all these different sources of data, sometimes that can be pretty messy. But I think one anecdote that I really like is, we sometimes do push to kind of make the real world a little bit cleaner, or at least the external world. There used to be this like one data source we'd get where we'd get a screenshot every day of like a table, right? And so in true HRT style, we were like, okay, let's automate this, right? So we built an OCR pipeline and we did all this stuff. But I think the really cool thing was we didn't just stop there, right? We then also went to that person who's giving us the data and we said, hey, can we work with you to build an API, right? And they were pretty happy to work with us, and so we are trying to push other people to be able to also make that better for everyone else who's using that data as well.
That way we didn't have to worry about them changing the font.
Yeah.
So model building, the process of going from research and raw data to trading strategies. Eric, what type of data do our strategies consume?
Yeah, I mean, there's kind of a pretty high diversity, and it can often be very tied to how far out you're predicting. If you're talking about very short-term prediction, very fast trading, then obviously the really fast market data is what's going to matter the most. But when you're predicting much farther out, potentially days or more, then there's an extremely wide diversity of information that you might want to filter into your strategies. It could be basically anything that is available to a computer could theoretically be information.
That's one thing to I guess communicate is HIT is simultaneously thinking about kind of sub-second timescales all the way through to days, and it's not always the same technological solution we have, I guess, for all timescales. And some of us work with some of those technologies, and some of us work with different ones. So Anita, you mentioned before you kind of worked on like intraday strategies. So like, what kind of data is like most relevant for you in your day-to-day work?
I think like on an intraday timescale, it's still mostly like market data. The other sources of data usually kicking like less often because like they are updated less often usually. Reading like raw market data and transform it into like a reliable aggregation of data that can be used for trading as a signal is very important. And then having that signal being like sent to the correct place for it to be like read is another process that's like very important.
It isn't like you have to go build a bespoke thing for each individual sort of strategy. It's like the whole flow.
Like generally, like setting up a new strategy is like not that much of work because like a lot of times like we just need to change like a few things that's like that specifies like okay which market we're doing this thing in, and then like things will just like automatically work and there's not that much of like brain damage to set off new stuff.
And one thing that's kind of interesting also is even when you're still talking about market data, the time horizon of your prediction can have a pretty big effect on what that even means, right? So if you're doing a very fast prediction, you'd be looking at every single message that comes off an exchange, and you'd be trying to do fast, potentially local processing of that. And you might not be able to look at every single symbol or every single security in the whole exchange. But if you're trying to do something with a longer prediction, you might put all of the data for all of the symbols into one large computation, and it's sort of a whole different class of things. And it also means you have to automate the creation of various, intermediate semi-processed data, like maybe the price every minute might be a really useful data set to have and a lot cheaper to process than every single thing that happened.
There's lots of intermediate steps of like the automated process of taking a series of like very low-level packets and transforming them reliably into some sort of high-level sort of processed version of the feed, and then taking that and then sampling it at different points in time, and then maybe rolling returns and all these sorts of things. And I guess one thing about this is that they all represent kind of like a natural flow, I guess. So I mean, I guess one of the neat things we have is automation of that kind of flow of data through different transformations and keeping it all up to date.
So one of the ways in which it's actually important to do this kind of end-to-end automation is you might say, well, why do we need to automate this entire pipeline? Why not just by hand create some data set that has, I don't know, the price and the volume once a minute or something like that, and then we'll just use that for a bunch of other research. But then you might say, well, what do we mean by the volume in a minute? What counts? Which exchanges are included in that? And do late reported things count, right? And you might want to be doing research on how the accumulation of this information feeds into how your signal behaves. And having a full end-to-end automation allows you to do that kind of study.
Yeah.
I think another interesting part about our automation system is that it's not completely automated in a way that it can only be automated. You can step in and do a manual thing and just have it perfectly fit into the whole picture of automating anything as much as you want. So you can interfere or mess with the system to make it do a thing, aka it's hacking the system. So I guess part of our job in automation that really differs from what you do in, let's say, a different tech company is that we're not trying to make things so robust that it's not hackable. We're making it safely hackable for our users who themselves are really good engineers who have wild research ideas all the time that they want to try out, but maybe the current automation system just doesn't really allow them to do that.
I mean, that's actually a really good point, I guess, in terms of HIT does have relationships with sort of external parties. You could call them customers. But for the most part, I guess our developers are thinking about developing trading strategies internally using the tools we create for our own purposes, which might be different from someone in tech working on cloud services where it's some deployment process for a customer.
I think another aspect of what you described that was really interesting is that in order to make these interfaces hackable, like you're describing, you sort of have to make them very non-monolithic. There might be a really high-level thing you can do, say, put your math here and out comes trades, but the steps beneath that shouldn't be opaque and only understood by a few people. It should be every layer makes sense and can be used in isolation, so that it's sort of, depending on how deep you want to modify the system, there's an easy way to do it.
So when you actually say that we do end-to-end automation, I was like, do we really do that? Because in my understanding, our automation is highly modularized in the sense that we do things step by step. It's not actually a automatic car. It's like a well-oiled manual car where you have 1,000 handles or switches you can turn on and off to control things, per your the things that you're trying to try out. So I guess in some way, sometimes we go from abstraction to automation. We figure out what is the abstract task that we want to do, and then we try to automate that. But sometimes we also go the other way around. We try to see what is the most easily automatable task. And maybe that's a natural blob of thing that should be its own, area of concern that we should separate out, or abstract out with the rest of the field.
I feel like there's some sort of car production line analogy happening here, right? It's like you've got some production line for a vehicle, and it's like it's like starts from steel things and gets belted into place. In the end, like a fully formed trading algorithm comes at the other end. But you can step in at any point and be like,
Exactly.
well, what if we paint the car red this time? Just to go faster.
One of the things that makes this possible is that there's a lot of openness internally, right? Like, a lot of the time you might want to make a modification to a component, but if you can't understand it, it's very difficult to understand what you might be able to change. But if you can actually see the code for it and modify the code for it, that enables a lot of research that is really difficult to do otherwise.
Yeah, and I know Harun was saying that the automation is end to end, but one thing that I think is nice about it is that it can be end to end. Like the goal is we do always want to capture ideas in code, and so if you wanted to, you could just run it, it'll do the right thing, it doesn't require any manual steps, and that's great. But I think the really exciting part about that is then you can pick and choose which parts you want to experiment with, right? Like if you're an AI researcher and you're just I want to tweak this model a little bit and see what will happen, you can just make a change to that part of the code, but then you can run the entire end-to-end thing and kind of see how the whole thing fits together, right? And you don't have to go, talk to another person as part of your development loop, right? You can just rapidly iterate on your part and see how it works in the context of everything else.
Yeah, I guess it goes back to the idea of caching intermediate results along this pipeline. Like a key part of that, making that possible, is that the things that are invariant relative to what you're testing are as quick as possible as well. It's not like every time you kind of push the make algorithm button that the whole thing runs from a blank slate. Even if it was automatic, it's like we can do better than that because the abstractions we define allow us to reason about what needs to be recalculated and what is novel, I guess, and then downstream affected by us. So we've talked a lot about how we kind of ingest data into our system, and then we've talked a little bit about how we might take that data and use it to make models, and then the implication is somewhere down the line you actually have something that interacts with markets. But before we do that, we want to kind of in practice, we want to kind of evaluate how that might do hypothetically. So that's this idea of backtesting and simulation. So, how do we sort of think about simulation and backtesting in this kind of automation sense?
Yeah, of course. So I think this really amazing thing that you cannot take for granted at HRT is that we run so many different strategies at so many different geographical locations, but we depend on the same one set of backtesting infrastructure for the most part to give us a sense of how our strategies would do in simulation before we put them up live. This actually enables us to do numerous research that could have gone bust in live world, right? So I think this really unblocks a ton of different research at HRT. And the way that we think about simulation, I guess, could be split into two parts. The first part is the simulation, engine itself, how we should design its API so that there's as little manual component to it as possible. And the second layer is that now that we have this, let's say a binary that runs simulation or backtesting for you, right? There are only a limited number of flavors of simulation or backtesting people would like to run in a normal workflow of research. So how do we automate that part and make it robust as possible to minimize human error or stuff like that? I think those are the things that we did a really good job on. We talk with researchers, all the time. We try to understand what is their use case, and we try to take out the abstraction from their use case and build something that could satisfy, let's say, more than one team's needs.
Yeah, I mean, taking a step back, I think sometimes we take this for granted, but in some sense, simulation is only possible because of automation. It's only because we're able to kind of take our trading ideas and put them in code that we can even answer this question of, what would have happened historically if we had run the same code, right? Like it's much harder to run simulation if you have like a human as part of your trading strategy.
Yeah, versioning and like stability. I mean, I guess the other thing is, even the idea of simulating and backtesting in this space is like inherently kind of, I wouldn't say unreliable, but like it's not literal truth, I guess, because one of the interesting things about markets, I guess, is your own. It doesn't exist independently of you. Our interactions with the markets have their own effects, and so I think there's a lot of like nuance in interpreting the results of our simulations and our backtests. So I guess like that goes back to the idea of having standardized reporting tools, so that when someone runs some sort of backtest, we can like reason about it and interpret it because they ran with these settings that I can reproduce myself, and I can see the consequences of changing different assumptions in our models and backtests.
Yeah, on the topic of standardized reporting, I think one thing that we've done a really good job of is having these like standardized reports that everyone knows where all the numbers are and what all the numbers mean. One thing you can really tell is whenever people post these reports, everyone knows what they mean and that people can trust the results. As opposed to sometimes people will do their own custom analysis, and we can trust those too, but only after someone goes and looks at exactly what the code did. And so I think one sense here of automation is with the standardized report, you already have cached in your brain like all the code that was run to generate that report, and so you can interpret the report very quickly.
Yeah, that's actually a really good point. We've talked a lot about automation as sort of saving like an individual's time. Like, I have a workflow and automation makes that workflow more efficient. I can get more work done per unit time. But I guess automation can also increase almost like trust and like aggregated time of everyone, because it's like you can almost pool like resources and understanding across people that way. And like that's actually a really good point.
That's right. It's like a reduced coordination cost.
Reduced coordination
Like,
costs.
you see this column called Sharp. Is it daily Sharp? Daily Sharp per symbol. Exactly what does this mean? Yeah. But if you've looked at 500 reports of this exact nature before, you know exactly what it means.
Yeah, and just to add more to that, like sometimes if it's not like a standardized like people that all use this report, like people could come up with like metrics that they just like individually prefer, and it would be like really hard for like other people to interpret, oh, what does this number mean? And like it's also really hard to tell other people, oh, this is actually pretty significant, whereas other people might just think that, oh, I've never seen this before, like maybe it's good, maybe it's not, how do I know?
Yeah, I mean, one of the little things that we do that I really like is the way, because we use Python extensively for a lot of our kind of glue to join all these different systems together, and so we use IPython notebooks a lot. And a lot of the tooling we've built over the years to make IPython notebooks like not only like a good like research experience, but also a good like sharing experience. Like we have tools to automatically like share notebooks, to run notebooks, to generate results from them, which I guess it's easy to take for granted, but it kind of again it's both the like reducing the cognitive overhead of like sharing results, but also like communicating and monitoring. So I guess it's worth talking about things that like are still not automated or inherently hard to automate. So I guess for a lot of its history, HIT is focused primarily on like central exchange traded products like stocks, futures, options, and so on. But there's a large and diverse market outside this world in the world of fixed income, where we are also spending more and more time thinking about. But these markets are very much not like these other markets in terms of their philosophy and automation. And it's interesting because I think part of it's cultural, and that people sort of don't want to automate necessarily. And maybe there's some arguments for it in that things it's harder to build the abstractions we talk about because these things that are traded are maybe inherently less abstractable over. But I think one big trend we've been seeing is there is still always a grinding trend towards automation and towards standardization in these markets.
Sometimes people neglect the power of automation of like seemingly trivial tasks, right? So we have this pipeline where like a user has to go in and check out the trunk and then commit some of the changes that's done by an automated job with their hands. It takes roughly like 5 minutes to go through the whole workflow, but you have to do it once per week, right? So 5 minutes once per week is definitely not a long time, and it's stayed manual for a very long time because it's hard to automate that part. But recently we found out that more than one team has been doing that for a very long time and for more than one workflow for the exact same problem. So actually devoted some resources of engineering into handling that. So it took probably 2 days for an engineer to actually make something that works reliably. But I think, the aggregated amount of time that was saved from algo developers from not doing that 5-minute task, which might actually take about 20 minutes out of the day per week, is actually not trivial. So I think sometimes people would let the semi-trivial manual tasks pass, but maybe there's still value in automating that.
Yeah. And integrated across many strategies and years, you could also imagine that probably saves a few mistakes.
Yeah, exactly.
Mistakes and context switches. I guess like that's the thing. Like something that takes 5 minutes of like literal straightforward time, but it's like you have to change what you're doing beforehand and then kind of change back to it afterwards. It is true, but those things like can add up to a lot. The same sort of automation is kind of a sense of like best practices that aren't kind of on the like. They're not like production automation. They're kind of just like all these auxiliary tasks that we might do in our day-to-day kind of like development environment. What is your like best practices for manipulating source control or sharing results in a notebook, or even just kind of like what packages do you pull in by default? Are things that over time we've tweaked and tried to automate and make standardized, all for just sort of shaving off just like little bits of time and like friction, but at like large scale over and over again for everyone, which really stacks up.
It actually is pretty significant. I remember just upon first arriving here, it was basically by the end of my first day, it was already possible to run large cluster computations. And I guess I had been expecting to spend my first day like configuring my editor and typing in the hosts that I needed to connect to for everything. But there was already like all the editors were configured. Everything was fine. All the packages I needed were there. And when I want to run code that someone else ran, it's no small feat that I basically just go to the appropriate directory and run the appropriate command, and it will use the same version of whatever libraries they used. And that doesn't happen automatically. I think it's taken a lot of work to get to that point.
Should we talk about the future of automation? What's everyone's predictions for what's next?
Oh, what is next?
The easy cop-out answer, but definitely true. It's just more. It's always just more automation. It's just one of those trend lines that just never fails.
Of the things that are not automated in your life right now, like what sort of properties do they have? Like, are there something about those things that are not automated that you think like future technology might solve, or is it just a case of us not sitting down and doing it yet?
There's definitely examples of both. In the first kind, I would say sometimes there are things that are just not easily accessible by computer program. And in those cases, you kind of have to have a human in the loop. And I guess my prediction would be that society will put more and more things into computers as time goes on. And then once those things are in computers, we will write programs to compute on those data.
What about you, Anita?
Well, for us, since our team is like newer, there are certainly things of the second kind that like we could have like, if we had time, we could have like done more of that automation on that end, but like we just haven't got the time to reach that point yet. But like for the first type, like I guess like there are certainly a lot of things that like maybe just like we don't know how to automate right now, but like I guess like I actually don't have a specific example in mind because like maybe like my imagination is just like too constrained, but like I certainly feel that like there are like a lot of stuff there.
Yeah, I think a lot of the time it's difficult to think more than one step ahead on making something automated. A lot of the time what will happen is you'll have some idea for some experiment that you want to do, and you'll run some large computation, and you'll realize that perhaps there were a number of steps that were fairly manual, and then you'll sort of do a bunch of work until the whole thing happens. You press one button and it happens. And you could say that at that point it's automated and there's nothing left to do, but What might then happen is as the code gets faster and now you're sort of just doing that all the time very easily, you realize that actually there's a pattern where you do this 10 times a day and you sort of create another outer loop. And there's like a whole nother stage of research that you could contain this experiment within. So I think a lot of the progression of what's happened over time has been something along those lines, where we're doing bigger and bigger experiments that contain what used to be things that were done by hand that are now done thousands of times.
Yeah, I mean, I'm pretty excited about the potential for a lot of the large language models that are being developed now. I think if you look at the core of what still hasn't been automated, it is a lot of the actual like writing of code or writing of design docs. And I think we still have to make a bunch of progress before we're out of a job. But in the meantime, I do think there is room for, as these technologies iteratively improve, to kind of make it easier for us to go from concept to design doc or to implementation. In the short term, actually, I'm really excited about even just like trying to do code review using some of these things. Like I've seen some pretty good demos of that.
Yeah, I do think these AI models also can. I guess I would use the word context. They have context in a way that like some more handcrafted automated approaches cannot do. I always think about like, if someone sees like a log file with various like warnings or kind of things, and we produce a large amount of logs every day from all our processes, and it's funny, like sometimes there is like a certain sequence of like things that might happen in the world that a human from context knows is something that is like an exceptional thing, but it's very hard to write any kind of like rule for that. But an AI system that has kind of got context of the wider world and can contextualize that could possibly, take an action where sort of previous approaches like might have fallen down. So I think that's something that I really get excited about. Just even if it was like, understanding news in the world, like, this thing happened in the world, so we should pause trading until it resolves. It's all very well to understand like a headline of 10 words and a kind of, if it's like, crudely good, bad, but sometimes it's much more subtle. And these are definitely a space where these like large language models might be able to like actually improve our trading in a measurable way.
What is our strategy if people that we interact with externally start to onboard more and more of these like new AI stuff? Let's say, what if one of the exchanges that we work with all of a sudden stop using humans, but using all like bots to write their data pipeline, and we get the result of that?
I mean, people have talked about the idea. Well, there, like I was talking about a little bit before, is all these products that are kind of traded, over the counter, which can mean a phone call or a chat message. Phone call, speech recognition, maybe a little bit flaky, but text. There's always amazing results of like AI and text. It seems quite natural to imagine that you could almost automate the process of having a chat conversation to trade some product. But it's also quite natural to imagine that the counterparty you're chatting with is also using an AI system to do that. So perhaps we'll get to a situation where we'll both be interacting with this AI intermediary, and then maybe one day it'll actually just be an API call. But until that point, maybe we'll be using large language models to talk to our counterparties to trade, bonds and all sorts of things. It seems very plausible this will happen a lot very soon.
So it's a very good API compatibility layer.
Yeah. Text, human text, human language, a universal API for all sorts of problems. Well, thank you everyone for joining us today for this conversation about automation. I think I actually thought about automation in a new light, after some of the things we talked about. And I hope to the audience at home that it kind of sheds some light on what HIT, how HIT thinks about automation, and how automation is changing at HIT, and how you can be a part of that. So apply online, and thanks for watching. I'm done. I want to go write some code in a dark room.